Hello everyone. I welcome you in my channel Science Tech, and in this lecture I will discuss all type of graphs used in AS physics. So let's start. First of all, I will discuss linear graphs. For example, if you have this equation y is equal to k times x, and you have to plot a graph of y versus x. You can see in this equation this k is constant. If this is constant, then y is directly proportional to x. So graph of y versus x will be a straight line, and this graph will pass through origin as there is no y-intercept. For example, if you have kx plus some number c, then this is y-intercept. But in this case, if you have only y equal to kx and you have to plot a graph of y versus x, then it will be a straight line passing through origin. Okay, so what is the gradient of this graph? The gradient of this graph is k. You know, equation of straight line is y equal to mx plus c. So this, the coefficient of this x is gradient. If you have y on this side, and then if your equation is in this form, then this is the coefficient of x is gradient, and this is y-intercept. Okay, so in other case, if you have, for example, this equation y equal to kx plus some number a, and you have to plot a graph of y versus x. And if you compare this equation with equation of straight line, then you can see this k is gradient and this a is y-intercept. So the graph between y and x will be a straight line with some y-intercept a, and its gradient will be this. On x-axis you have x and here you have y. So gradient is k. Okay. So in other case, if you have this type of graph, y is equal to expression y equal to some constant k x square. So you can see from this relation that y is directly proportional to square of x. Y is not directly proportional to x, but it is directly proportional to square of x. Y is proportional to square of x. So if you plot y versus x square, then you will get a straight line because y is proportional to x square. So it will be a straight line passing through origin, and the gradient of this graph will be k. Gradient is k. But if you have to plot y versus x, then it will not be a linear graph. You can easily see that y is not proportional to x. Okay, so if you have to plot on x-axis, you have to plot x, and on y-axis you have y. Then this will be a non-linear graph, parabolic form, and the shape will be like this. Okay, this is very important situation. So if y is proportional to x square and you plot x square versus y, you will get a straight line, and if you plot y versus x, you will get a parabolic shape like this. You have seen these type of graphs in your O-level mathematics. Okay, so y versus if y is proportional to x square, and then y versus x will be in this form. Okay, so you can easily see what type of situation in real exam where you face this situation. You know that elastic potential energy is in deformation chapter, elastic potential energy EP is of kx square. Okay, where x is extension or compression of the spring, and EP is elastic potential energy, and K is spring constant. And if you have been, if you are, you have to identify the graph between EP versus x square, then it will be a straight line. But if you have to sketch the graph, mostly you have to identify the graphs in your exam. And in paper 2, you may have to draw the graph as well. So EP versus x will be in this form. Okay. So this is how you sketch the graph between x and y if it is x square. Okay. For example, another situation is if you drop an object from some height, this is height h. Okay, and there is no air resistance. You know that initial velocity is 0 as you dropped it from west. So how this distance x varies with time? This is, let's say this distance is s, and this distance varies. You know, equation of motion is ut plus half at square. Ut plus half at square, and you know that u is 0, so s is half at square. Okay, so you can see that s is proportional to t square. S is proportional to t square, where as acceleration is constant. So if you have to sketch the graph between s versus t square, it will be a straight line. And what is the gradient of this graph? If you compare this graph with equation of straight line, this is your y, and t square is your x, so this is your gradient. So gradient in this case will be 1 by 2 g. This is gravitational acceleration. So from this graph, you can find gravitational acceleration as 2 times gradient. But if you have to plot a graph of t versus s, then this will not be a straight line, and this will be in this form. So graph of t, if you plot t over here and distance s over here, your graph will look like in this form. Okay, so this is a very important situation where you have to identify a graph of quadratic function. Another situation is if you have graph of your equation is look like this: y is equal to some constant k, and there is square root of x. This is again very important situation. So you can see from this equation is that y is proportional to square root of x. So if you have to plot a graph of y versus square root of x, then it will be a straight line. If you have square root of x on x-axis versus y, then it will be a straight line. You can easily see from this equation that y is proportional to square root of x. So it will be a straight line. And what would be the gradient? You can easily identify by comparing this with equation of straight line. The gradient in this case will be constant k. Okay. So, but if you have to plot this y versus x, y versus x, then the graph will look like this. This is the graph of y versus x if you have the expression that y is proportional to square root of x. So if y is proportional to x square, then the graph of y versus x will be a parabolic shape. And if y is equal to some constant k times square root of x, then the graph will be in this form. And where you face this situation in exam, there are multiple situations where you have this type of graph. For example, if you throw a projectile from some height with initial horizontal velocity, let's say this velocity is v, and you throw it from height h, let's say it lands at distance x from this surface. The horizontal distance is x. You can easily prove that. I will not enter into the discussion of proving x versus h, but you can easily prove that using projectile motion that x is, you know that horizontal velocity is constant, so x is v times t. Okay, this is horizontal velocity, and vertical acceleration is constant, so this h is ut. Vertical initial velocity is 0, so it is half gt square. If you use these two equations to find a relationship between x and h, you will get this type of relationship, 2h over g. You can see from this relationship that x is, this v is constant, g is constant, 2 is constant. So we can easily say that if we put all of these constants as single constant k, then x is proportional to square root of h. Okay. So if you have x on y-axis versus h on x-axis, then your graph will look like this. Okay. But if you plot square root of h versus x, square root of x, h versus x, if you are given this situation, then your graph will look like this. Okay. But on the other hand, if you have to determine the relationship between v and x, you are keeping the height constant. And if you are throwing this object with different initial velocities, what are you doing? You are changing initial velocity v and you are keeping h constant, then x is directly proportional to v. Then the graph of x versus h will be x versus v, sorry, will be a straight line. So the graph of x versus v will be a straight line passing through origin if h is constant. Okay. So this is another important situation where you have this type of relationship. Okay. So now if you have this situation, y is equal to k over x, where k is constant, and you have to determine the relationship between y and x. So if you plot y on x, y-axis versus x, will it be a straight line? The answer is no, because this is not in this form. Y is not proportional to x, but y is inversely proportional to x. Okay. So as x increases, y would decrease, but in non-linear fashion. So at x is 0, y will be some, at x0, y will be infinity, and as x increases, y would decrease, and it will not touch on these two x's, because at x equal to 0, y would be infinity, and at x very large, at x, as x approaches to infinity, y would become 0. Okay, so this graph will not touch these two axes. But if you have to plot a graph of y versus, you can easily see from here that y is directly proportional to 1 over x. Y is directly proportional to 1 over x. So if I put 1 over x as a single variable, then y is proportional to 1 over x. So instead of x on x-axis, if I put 1 over x on x-axis versus y, then the graph will be a straight line. So in this situation, if I put 1 over x on this axis versus y, then I will get a straight line relationship. And the gradient of this graph will be k. So we can solve this important situation of exam. Objects, let's do this situation. This is a past paper situation. Objects with different masses are placed on the horizontal surface of a table. The objects are then raised to different heights above the table. The gain in gravitational potential energy of each object is the same. So what's important? EP is same, potential energy gain is same for all. So which graph best shows the variation of h of the object above the table with their mass? What we have to determine, the relationship between h versus m. How would you tackle this question? You know that change in potential energy is mg change in height. So what is being changed in this question? The height and masses are being changed, whereas EP and G is constant. Okay. So if I make H as subject of formula, I will get EP over mg. So As EP is constant, G is constant, so I can easily say that H is inversely proportional to M. So, as I discussed in this situation, if you have this type of graph, Y is 1 over X, and you have to plot X versus Y, you will get this type of graph. So, this situation is exactly similar to that I discussed. So, as M increases, H would decrease. Okay. So, the relationship between H and M is non-linear relationship. So the option A is the correct choice. As M increases, H would decrease in this style, and it will not touch these both axes. Okay. So in this graph, as M increases, H increases. For the same potential energy, M versus H relationship is non-linear relationship, and it's inverse relationship. Okay. So over here, in this graph, H is proportional to M square. This is graph of M square versus H. And over here, H is constant. H is not changing with M. So another situation, we can easily see the diagram shows the variation of a quantity Y versus a quantity X. Quantity Y versus quantity X. So for the objects in the uniform gravitation field, the gravitation field is constant, so that is not being changed. This is quantity Y versus X. So you can easily see from this graph that Y is proportional to X square. This is graph of parabola. So what a real situation matches with this graph? We have to determine that what real situation matches with this graph. So you can think about that situation. So you should try your level best, and then you should see my answer. So let's see. So in option A, mass for different objects moving at the same speed. Mass for different objects moving at the same speed versus kinetic energy. You know that kinetic energy is equal to half mv square. So over here, speed is same. And then if we have to look the relationship between mass and kinetic energy, if the speed is same, then the kinetic energy will be directly proportional to m. And the graph of kinetic energy versus if x is kinetic energy, what is this? If x is mass and y is kinetic energy, then mass versus kinetic energy graph will be a straight line. So option A is incorrect. Let's look at option B, the speed of an object of constant mass, speed of an object of constant mass versus kinetic energy. So on x-axis is the speed versus kinetic energy. You know that kinetic energy is proportional to v square. So if on x-axis you have speed and on y-axis you have kinetic energy, then this option will be correct, because you know that kinetic energy is proportional to the square of speed. And if on x-axis you have speed and on y-axis you have kinetic energy, then the kinetic energy is proportional to v square. So on x-axis, if you plot a speed and if you plot on y-axis kinetic energy, then this will be a right option, parabolic shape. So if you plot v square on x-axis versus kinetic energy, then it will be a straight line. Okay. So let's do another situation. So we have discussed different type of graphs, and now I will put more examples. So let's say you have this type of relation, y is equal to sine theta, and on x-axis if you have theta, and let me draw shapes over here. Okay, so if you have y versus, if you have to plot a graph of y versus sine of theta, if on x-axis you have theta, on y-axis you have y, then the graph of sine theta versus y will be a nonlinear graph, and it is a graph of sine. It will be of this form. Okay, so at 90-degree, sine of 90 is 1. At 180-degree, it is 0. At 270-degree, it is -1. And at 360-degree, it is 0 then. But if you have sine theta on y-axis versus y, then what do you expect? You expect that y is proportional to sine theta. So the graph will be a straight line because y is directly proportional to sine theta. And over here, gradient will be 1. As the coefficient is 1, so the gradient is 1. And if you have to sketch a graph y between y and some k cos of theta, and if on x-axis you have theta and y-axis you have y, then the graph of cos theta versus y will be this is one period. So over here it will be k, the magnitude is k, the maximum value is k. You know that the maximum value of cos theta is 1. So the maximum value of y in this case will be k, and minimum value of y will be minus k. Okay, so at 90 it would be 0, at 180 it would be minus k, 270 it would be 0, at 360 it would be positive k. But graph of cos theta versus y will be a straight line with gradient k. So why do we need to study this type of situation, graph of cos and sine? Let me explain. You know that if you have this force, and this is theta, so this is x component, and this is its y component. You know that x component of this force will be F cos theta, and y component of this force will be perpendicular component opposite to this angle will be f sine theta. So in exam, I have seen a paper where he asked the relationship between fx versus theta. So x component versus theta will be, theta is varied from 0 till 90. So fx would decrease to 0 as theta is increased from 0 till 90. Okay. And this value will be f. Okay. So you know that in diffraction grating, the equation of diffraction grating is d sine theta is equal to n lambda, where n is the order of maxima, this is wavelength, this is theta of nth order with frontal line, and d is the distance between two slits of diffraction grating. So if on y-axis I plot sine theta, and on x-axis I plot lambda. So what's the relationship between sine theta and lambda for any fixed order? You can see from this equation that sine theta is n lambda over d. And sine theta is proportional to wavelength. What are we doing? We are changing the wavelength and we are observing or measuring the corresponding angle of any fixed order n. So if we plot a graph of sine theta versus lambda for any fixed order, what type of graph would we expect? We would expect a straight line relationship because sine theta is proportional to wavelength. So what's the gradient of this graph? The gradient of this graph will be n over d. The gradient of this graph will be n over d. It's a very important situation. And you know that in double slit, the fringe spacing distance between two bright fringes or distance between two dark fringes is x is equal to lambda d over a, where d is the distance of the double slit from distance of screen from double slit, x is fringe spacing, a is the distance between two slits, and this lambda is wavelength. So if we have to plot a graph of x versus lambda, what we are going to change? We are going to change wavelength, and we are observing the relationship between x versus lambda, then it will be a straight line. And the gradient will be d over a. But if we are, this is also, x is also proportional to d. If we are changing the distance of the screen from the slits, and we are keeping wavelength and a constant, then the relationship between x versus d will be a straight line. And another end, if we are changing slits, so we are changing a, then the relationship between x and a is inversely proportional, and it would be a nonlinear graph. It will be like this. Okay, so x versus 1 over a would be a straight line like this. If we plot 1 over a on over here and x on the y-axis, then we will get a straight line relationship. So okay, so if you have this type of relationship, y is equal to A cos square theta. And the relationship between theta versus y would be, you know that the if you take the square of cos, then it would become positive. So the value of y will not be negative in this case because you are taking square of cos. So the graph would look like this. What are we going to do? We are taking the square of cos. So at 90 degree it would be 0, and at 180 degree it would be a, and at 270 degree it would be again 0, and at 360 degree it would be maximum. This is graph of y versus theta. But if you have to plot of graph of y versus cos square theta, if on x-axis you have cos square theta, then the graph will be a straight line with gradient a. So in real situation, where do you face this type of situation in AS physics? You know that in polarization, the intensity of wave after passing a polarizer is given by I naught cos square theta. This is intensity before the polarizer, and this is theta, the angle with which the polarizer has been rotated with reference to the previous axis, and this is intensity after passing the polarizer. So the graph of theta versus I would be like this. Over here, on y-axis you will have I, and this will be I naught, and the graph will be exactly similar to this. So that's why I told you this graph. Another important situation, you know that elastic potential energy is half kx square. So if on y-axis you have, I have seen a question where on y-axis it is tension, on x-axis it is elastic potential energy. So what would be the graph? What type of graph do you expect between x, if x is on y-axis, and elastic potential energy on x-axis? So first of all, what you will do, you have to make x as a subject of formula. So x square is 2 EP over k. And you have to take square on both sides, that is 2 over k times square root of EP. This whole stuff is constant, and you can easily say that x is directly proportional to the square of EP, and the graph between EP versus x, this is similar to the y is square root of x. If on y-axis you have to plot y, on x-axis you have x, then the graph will be like this. This is again very important situation. Okay, so another important situation is if you have, you know that resistance of a resistor is rho, resistance of a wire is given by this formula, and where L is the length of wire and A is cross-sectional area. So resistance versus L will be a straight line. If you're changing L, you're keeping A constant, then it will be a straight line. And if you are keeping L same and you are changing A cross-sectional area, then the graph would be in this form. And if you are plotting 1 by A versus R, then it will be a straight line. Another important situation that has been asked many times, that what are you going to do? You are keeping the volume same, V same, and you are changing the length. Changing length. If we change length and we keep volume same, then the area has to decrease. Then what type of relationship between resistance and L would be? You know that volume of this wire will be cross-sectional area time L. And we are changing length L and keeping volume same. So if we put area as V by L from this relationship in over here, then we will get rho L divided by V by L. Then it would be the resistance is rho L square by V. You know that rho is the resistivity of wire that is kept constant, that is same for same wire, and V is kept constant over here. So resistance is directly proportional to L square. So if you plot a graph of L versus resistance, then you will have this type of graph. And if you plot a graph of L square versus resistance, you will have this type of graph. On the other hand, if you keep the volume same and you change the cross-sectional area, now what are you doing? You are changing the cross-sectional area and you are keeping the volume constant. So your relationship would look like rho L over A, and you know that volume is L. Now you should replace L versus by V by A, because you are keeping the volume same and you are changing A, so you need a relationship between R and A. So this is V over A divided by A, rho V by A square. This is again very important relation. So resistance is inversely proportional to A square. If you plot A square versus resistance, then it would be in this way. And if you plot, now if you plot 1 over A square versus resistance, then it will be a straight line, because 1 over A square is kept on x-axis. Then if we replace this with x and we replace this with y, then y is rho v x, and the gradient of this graph will be rho v. Okay, so this is again very important situation. If you have y versus k over x square, and if you plot a graph of x versus y, as x increases, y would decrease. It would be this way. And if x is negative, y would be positive. So the graph will be on this axis would be like this. So this is again very important. Now, I should explain one more important situation. For example, if you have this is a water surface, any liquid it can be, and you have an object of a cubical shape. what are you going to do? You are going to move this object into the liquid. You are going to move this object into the liquid and then see how the upthrust changes with height, with depth. You know that upthrust is rho g v. This is volume of liquid displaced, and this is the density of the liquid. So initially, if this object is not inside the liquid, the upthrust would be 0. It will start from here. This is depth versus, we are plotting a graph of depth versus upthrust. So it would start from 0. As it moves down, as this object moves down, depth increases, volume of liquid displaced increases. So upthrust would increase. Rho g, area of this object, cross-sectional area, times the depth. Let's say this is x. So upthrust would be directly proportional to this. So upthrust will increase. Tell if the object becomes completely submerged in the liquid like this, then the upthrust will be maximum. After this, if you further decrease or move this object down, the upthrust would not further increase. Rather, it will be a constant because the liquid displaced, the volume of liquid displaced would not further change. Another important situation is very important. For example, if you drop an object from some height, the mass of this object is m, and we are going to see that how its potential energy changes with this distance. This is the distance. We are measuring this distance from this initial position. When x is 0, its potential energy versus x graph. So when x is 0, its potential energy will be maximum. As x increases, this object goes down, potential energy would decrease, and it would become 0. We are measuring potential energy with reference to this height. So potential energy would decrease. So how would it decrease? Will it decrease in a straight line fashion like this or like this? How we would see? How we would determine that in which style the potential energy would change? Can you guess that? So let's do that. Air resistance is 0. There is no friction force, air resistance. You know that S is, the distance S will vary in this way. S is, you use this equation, 2AS is V square minus U square. Okay. As U is 0, so potential energy, the distance, we are going to find the potential energy graph versus distance. So what do you expect that how the potential energy changes? So let's see this potential energies would change like this. Initially, potential energy is maximum. Let's say this is E naught minus mg x. Okay. As distance x increases, the potential energy would decrease. The potential energy would decrease. So the graph between x versus potential energy will be a straight line. Initially it is maximum, that is the maximum potential energy that it had at the start, and as x increases, potential energy will decrease, and at some h, that was the initial height, the potential energy would become zero. So we have to use this graph, not this relationship, not this. But if you have to plot a graph of potential energy versus time, then what would you expect? You have to involve time in your equation. Okay, so potential energy is initial maximum potential energy minus, you know that, mgx. Now we have to replace this x. We have to bring time over there. You know that 2a x is, or s is ut plus of at square. This distance x varies in this style. So u is 0. So distance x will be 1 by 2 g t square. So the graph would be EP is E naught minus mg, and this x would be half gt square. This stuff is constant. So EP would change with t square, and the graph, you know that y is, if you have y is a minus x square, the graph will look like this. We have seen this in the whole. So the potential energy would decrease with time t by. What about kinetic energy? If potential energy is decreasing, then the kinetic energy would increase. And you know that kinetic energy is E case of mv square. And V2s is equal to v square minus u square, and u square is 0. So v square is 2ax. This distance s is x. So kinetic energy is half m2gx. So kinetic energy would increase with x, linearly increase with x. So graph of kinetic energy versus x would be linear relation, a straight line. But if you have to plot kinetic energy versus time, then you have to replace this x with time. You have to see how the displacement changes with time. Okay, so kinetic energy is how m g x. So our kinetic energy is half mv square. So velocity is v is u plus at. U is 0, so v is at. So kinetic energy will be 1 by 2 m a square t square. So kinetic energy is, with t would be like this. One last situation. You can see in this graph, in this question, that a battery is connected to potentiometer. Potentiometer consists of uniform resistance wire. This is uniform resistance wire. And potential difference between 2 points Q and P is measured. And we have to check the relationship between V and D. So you know that resistance of wire is rho L over A. If area is constant, over here area is constant, resistivity is constant, then the resistance is directly proportional to it. And according to potential divider formula, the potential between these 2 points is resistance of this part of wire D, I would say D, divided by total resistance, that is L naught over A times the EMF of this source. You know that. Then this would cancel out. The potential difference is D L naught over E. So the potential E is same, L naught is same. So the potential difference is directly proportional to D. So the graph between B and D is a straight line. So again, very important question. So I hope you understand what has been taught in this video. And if it is helpful to you, please share with all your fellows. I hope it is helpful.